At some point in your developer career, you're going to be stuck with a query that seems to just take forever to finish executing. Digging into the diagnostics for query optimization can not only be daunting, but it can be downright terrifying. The truth though is, most queries' performance issues can be solved with a few simple checks. So today I'm going to give you 4 easy steps that you should always try first when dealing with a query that is running particularly slowly. Firstly, you should check for indexes. Make sure you have table indexes in all the right places that your query will utilize. Indexes help speed up searches by allowing the database to quickly locate specific data without having to look through every single record. You can think of database indexes just like the index of the back of a book. If you were looking for a specific word in a book, instead of having to read every single page to find out if that word exists, you could jump straight to the back of the index, look for that word in the index, and it would tell you on which pages those words appear. Then you only need to go through those particular pages to find the word you're looking for. Database indexes work in a very similar way. You really want the database engine to always be using an index whenever it's trying to find a record or records. Knowing where to put an index is not particularly complicated. If you're not sure where to put your indexes, a good rule of thumb is to put them on your foreign keys where the joins are going to be happening, or the fields that you're going to use in your where clause or your order bys. And most database management tools will tell you when you're missing an index or where you've got a particularly inefficient index. There are some caveats to using indexes. While they dramatically reduce the speed that it takes to perform read operations, it slightly increases the write operations like inserts or updates, deletes. In the real world, in my experiences, I've found this to be completely negligible. Next up, look at some of the structural inefficiencies which you can avoid. Developers new to relational databases will often fall back to using cursors just because it feels familiar, using it in the same way you would a loop in another high-level language. This approach is particularly bad. Using cursors in general should only be used if you really have a specific reason for using cursors. These should be swapped out for set-based operations, or operations that work on an entire set of data, rather than looping through the set and working on each individual row. Avoid using subqueries, especially wherever you have a where clause or a having. These are essentially nested queries. Most of the time you can use a join to get the same output. Exist rather than looking for a set of results within another query. This is because exist will return a result after it finds a single match, whereas in will continue to scan through the results until finding all matches. Do not use distinct unless you really have to. Distinct is particularly expensive because it needs to compare a single row to all the other rows in the table to look for duplicates. Narrowing down on your where clause is often a good way to avoid having to actually use the distinct clause. Return only what you need to return. Don't use select star because this will return every single field in your table, whether you plan on using it in your client application or not. Every bit of data you're pulling down over the wire is a performance hindrance, especially if some of your fields are storing files in blob data or large sets of text. You really want to only return the fields that you need and will use. Same really applies to the number of rows you're returning. Don't return 10 million records if you're only ever going to look at the first 3. Use the top or the limit statement to keep the number of rows to the number that you'll actually be concerned with. Avoid using wildcards. Especially don't use a wildcard at the beginning of your search term. This is because it prevents the database engine from using an index. The reason is because the index is built from left to right. So if you're putting a wildcard at the beginning of the term, it's causing the database engine to look at or scan every single record in that table. So there's some quick tips that I hope will help you out debugging your slow queries. Thank you so much for watching. Try one of my other videos if you like, and I will see you in the next video.